Example 4. Car A is traveling west at 50 miles per hour and car B is traveling north at 60 miles per hour. Both are headed for the intersection of the two roads. At what rate are the cars approaching each other when car A is 0.3 miles and car B is 0.4 miles from the intersection? Okay, so if we have car A, which is here, okay, and we know that it's moving west. And if it's moving west, it's at 0.3 miles. And we know that the rate that it's traveling at is equal to 50 miles per hour. And then we have car B, which is traveling north. And that car is 0.4 miles from the intersection, since this is the intersection here. And we know that the rate, and I'm going to use lowercase b here, and this is A. We know that the rate for car B is 60 miles per hour. Okay, so what we want to do first is we want to find out what is the distance between A and B. So if we take a look at that, okay, we're going to want to find the distance between A and B. Okay, so if we have this intersection, okay, this is going to form a triangle, a right triangle. So what we would like to do, okay, is we want to figure out what is the value of this here, which we're going to call it C. So if we think of this as a Pythagorean theorem, okay, we can call this lowercase a and we can call this lowercase b. So the Pythagorean theorem states that if we have a squared and then we add b squared and let that equal c squared. Okay, well, we know that the distance from car A to the intersection is 0.3 miles. So this is going to be 0.3 squared plus the distance from car B to the intersection is 0.4 miles. So that's going to be 0.4 squared, and that's equal to c squared. So if we square 0.3, we get 0.09, and if we square 0.4, we get 0.16, and that's equal to c squared. And if we add those together, we get 0.25, which is equal to c squared. And if we take the square root of both sides, then we're going to know and find that c is going to equal 0.5. Okay, now, again, we want to know at what rate are the cars approaching each other. So in order to do that, we're going to use the Pythagorean theorem, a squared plus b squared, which is equal to c squared. Okay? And so what do we know? We know that the derivative of a with respect to t, which is the rate for car A, is 50 miles per hour. We know that the derivative of b with respect to t, and that rate is traveling at 60 miles per hour. So we know that the values in this case here, as it goes in this direction and as it goes in that direction, it's slowing down when it gets to the intersection. So that means that this is going to be negative 50 miles per hour and this is going to be negative 60 miles per hour. Okay? And then we also know that the value of c is going to equal 0.5. So that means we're going to be looking for the rate dc of dt, and that's what we're going to be looking for. So now what we're going to do is we're going to take the derivative of each term. So the derivative of a squared is going to be, and we're going to write that here, we're going to have 2a times the derivative of a with respect to t plus 2b times the derivative of b with respect to t, and then that's equal to 2c times the derivative of c with respect to t. So now we're going to plug in our information. So we have 2 times the value of a, which we know is 0.3. We know that the derivative of a over dt is going to be negative 50, plus 2 times the value of b, which is 0.4, times the derivative of b with respect to t is negative 60. And that's going to equal 2 times the value of c, which is 0.5, times dc over dt. So when we multiply 2 times 0.3 times negative 50, we get negative 30. We multiply 2 times 0.4 times negative 60, it's going to give us negative 48. And that's going to equal 2 times 0.5. Well, what's 2 times 0.5? Well, that's 1. So we have dc over dt. So therefore, we know that the rate where the cars are approaching each other, which is dc over dt, is going to equal negative 78 miles per hour.